All right, in 11.2, we're going to talk about multiplying matrices. So, just like in 11.1, there are specific things that need to be in place to determine if you can actually combine the two matrices by multiplication. So, we're going to write that in first. What we're going to check for is we need the columns in matrix A to be equal to the rows in matrix B. So remember, dimensions are rows by columns. So if we're trying to determine if they have the same. So for example, if we say that the rows and columns of matrix A are m times n, and that the dimensions of B are n times p, we need these two n's to be the same. That's what we're aiming for. If they are, then you can actually determine the dimensions of your resulting matrix, or the product of those two things, and it should be m times p. So in other words, it's the rows of the first matrix, and it's the columns of the second matrix. And that might seem a little crazy without actually seeing an example. So let's kind of look at one, and then hopefully it makes a little more sense. So let's review how to do our dimensions. So we've got rows by columns. This has 3 rows and 2 columns, making this a 3 by 2. This matrix has 1 row and 2 columns, making it a 1 by 2. So the only way we can multiply these is if these two numbers are the same, and they are not. So this is not a pair where we could multiply these together. So let's look at B. We have 1, 2, 3, 4, 5 rows and 3 columns, making this a 5 by 3. Then our second matrix has 3 rows and 4 columns, making it a 3 by 4. And we have a match. So these two can indeed be multiplied because these two are equal. However, it also gives us enough information to state the dimensions of AB. So the resulting matrix that we would get after multiplying these are the rows of your first one and the columns of your second one. So I know the resulting matrix should be a 5 by 4, which is kind of nice to know to make sure, 1, you're doing it correctly, but 2, that how big to make your workspace as you work through these problems, because you'll know what to expect when it's over. All right, now I went ahead and wrote this in so you can get an idea what this is going to look like as far as the process when it comes to multiply. So here you'll realize we have a 2 by 2 times a 2 by 2. So yes, they do match, so we can multiply these together. So the process of doing this, and I'm going to show it to you in words, then show you this example, and then we'll do a few together. But when you multiply, you're going to take the elements of each row of their first matrix, and you're going to multiply them to all the elements of each column in the second matrix. Which is why those two middle numbers and your dimensions need to match. Then, after you've found all those products, you're going to add them up. So you'll notice here, so just look at one of our items. Our first row here is A and B, and our first column is E and G. So the first multiplication I would do would be A times E and B times G, and then I would add them together. So the first element of the row gets multiplied to the first element of the column, and then you just move your way through it until your row and column is complete. Then you take those two products and you add them together. And then you repeat that process until you have your entire resulting matrix. So let's try this out. I'm going to try and color code it to assist, if that helps at all. So first off, let's check to make sure it can actually be multiplied. So this is a 2 by 2, as is this. So yes, we do have this number that matches. So we can multiply these together, and our resulting matrix should be a 2 by 2 as well. All right, so we're going to focus on, I'm going to highlight the rows we're working on. 1 times 4 times 5 times 9. So first row goes to the first column. So the first element in each is a 1 and a 5. So I'm going to take 1 times 5. Let me zoom out so we can see what we're doing as I write. Then the second item is element is a 4 in the row and a 9 in the column. And then we would add these two products together. So eventually our first row, first column value should be 5 plus 36, which is 41. All right, so let's look at our next one. So we're going to stick with the first row, but now we're doing the second column. And that will give us the next part of our multiplication. So we're going to take 1 again times 0 plus 4 times 6. So 1 and 0 are the first row and first part of the column. 4 is the second part. 6 is the second part. Now, another thing you're going to notice is you should see some repeat. There should be some patterns that you'll see if you show this like in between matrix, this in essence showing your work. Oops. So sometimes that can help. Sometimes it may not, but hopefully showing your work will help. All right, so now we're going to go to our second row. We're going to take 3 times 2, and we're going to multiply it times 5 and 9. So let me go ahead and use my magnifying glass again. So we have 3 times 5, so the first part of our second row, times the first part of the first column, plus 2 times 9. And then last but not least, we're going to go second column, second row, which gives us 3 times 0 plus 2 times 6. So that's kind of the in-between matrix. This is showing you the work we're doing. That will take us eventually to our final answer. So if you want to enter these in a calculator, feel free. So again, the first one is 1 times 5 plus 4 times 9, which gives us 41. Then we have 1 times 0 plus 4 times 6, which gives us 24. Next we have 3 times 5 plus 2 times 9, which gives us 33. And then 3 times 0 plus 2 times 6, which gives us 12. This is our final answer, or the product of A, B. Now, this process can be tricky. So the more work you show, the easier it hopefully would be as you work through where all of your elements should go. The more you do it, the easier it does get. Again, if you'd like to pause this and then work number 3 and then come back, feel free. Again, I'm going to check first to make sure these two things can be multiplied. So here we have a 3 by 2, and here we have a 2 by 3. So those do indeed match up. The 2's match, and the dimensions of our final matrix should be a 3 by 3. All right, I'm going to do a little less color coding on this one to kind of speed it up. So first we have one times 0. Sorry, not 1 times 0. 1 times 2 plus 0 times 4. That's the first row, first column. Then we have 1 and 0 again, so 1 times 8, going down our second column, plus 0 times a negative 2. Still going on the first row, so we have 1 times 1 now, plus 0 times 0. And that should be all of our first row. So you'll notice you see that 1 and 0 duplicate itself because we're using the same row every single time as we floated through our columns. All right, next one. So we have negative 2 times 2 plus 1 times 4. Then we have negative 2 times 8 as we move on to that second column, plus 1 times a negative 2. Then we have negative 2 times 1 plus 1 times 0. All right, our final column here, final row, going through all 3 columns. So we have 5 times 2 plus 7 times 4. Then 5 times 8 plus 7 times a negative 2. Then 5 times 1 plus 7 times 0. All right, so that should be kind of like our matrix that's showing all of our work. And then we can go ahead and write our answer down over here. Again, it should be a 3 by 3, so we should end up with 3 rows and 3 columns. So if I enter these in, you can do it on your calculator. 1 times 2 plus 0 plus 4, 0 times 4 should be 2. 1 times 8 plus 0 times negative 2 should be 8. 1 times 1 plus 0 times 0 is just 1. Negative 2 times 2 plus 1 times 4 is 0. Negative 2 times 8 plus 1 times a negative 2 is negative 18. Negative 2 times 1 plus 1 times 0 is negative 2. Five times 2 plus 7 times 4 is 38. Five times 8 plus 7 times a negative 2 is 26. And then last but not least, 5 times 1 plus 7 times 0 is 5. And that is your final matrix.